According to the National Electrical Code, service entrance conductors are required to be securely fastened within 6 inches of every support and in no case more than 12 feet apart. This is outlined in NEC section 230.14a. It is common practice to provide additional lashing or support for service entrance conductors where they are exposed to potential movement or stress, such as at the point of entry into a service entrance box. This is especially important for large conductors such as 600 kc mil. With 5 to 6 feet of conductor exposed and multiple parallel runs, additional lashing is highly recommended. This will help to prevent the conductors from moving excessively during a fault condition, which could damage the main lugs or other components within the box. For a recommended lashing method, firstly, use non-metallic cable ties or stainless steel lashing wire. Secondly, loop the lashing material around the conductors and the rim of the box. Thirdly, tighten the lashing material to secure the conductors, but avoid over-tightening. Allow for some slack to accommodate conductor expansion and contraction. Additional considerations include making sure the lashing material is rated for outdoor use. Inspect the lashing periodically and retighten as needed. Consider using a cable tray or conduit to provide support and protection for the conductors from the point of entry into the box to the main lugs. The NEC mandates specific requirements for supporting service entrance conductors to ensure safety and prevent potential hazards. These requirements are designed to minimize stress on connections and equipment during normal operation in fault conditions. The primary NEC section governing the support of service entrance conductors is 230.14a, which states that service entrance conductors must be securely fastened within 6 inches of every point of support and at intervals not exceeding 12 feet. This means that any point where the conductor is attached to a structure, such as a building wall or a support bracket, must have a fastener within 6 inches to prevent excessive movement. For horizontal runs, the maximum distance between supports should not exceed 12 feet. This requirement ensures that the conductors are adequately supported along their length, preventing sagging and potential damage. When conductors enter an enclosure, such as a service entrance box or a meter socket, they must be supported within 6 inches of the enclosure. This support helps to reduce strain on the terminals and connections inside the enclosure. In cases where conductors pass through walls or floors, they should be supported on both sides of the penetration to maintain stability and prevent chafing. The type of support used for service entrance conductors must be suitable for the environment and the type of conductor being supported. Common types of supports include insulators, cable ties, and straps. Insulators are typically used for bare conductors to provide electrical isolation from the support structure. Cable ties and straps are used for insulated conductors to provide mechanical support. The support must be strong enough to withstand the weight of the conductors and any additional stress caused by wind, ice, or other environmental factors. In addition to the NEC requirements, local codes and regulations may have additional requirements for supporting service entrance conductors. These local codes may be more stringent than the NEC and should be consulted to ensure compliance. Proper support of service entrance conductors is essential for maintaining a safe and reliable electrical system. Failure to properly support conductors can lead to a number of problems, including conductor damage, insulation breakdown, and even electrical fires. By following the NEC requirements and local codes, electrical contractors can ensure that service entrance conductors are properly supported and that the electrical system is safe and reliable. The common practice of lashing service entrance conductors provides additional security and stability beyond the basic NEC requirements. Lashing involves using materials like non-metallic cable ties or stainless steel wire to bundle and secure the conductors together, especially in areas where they might be subject to movement or stress. This practice is particularly beneficial in situations where the conductors have long spans between supports or where they enter enclosures like the top hat box. In the described scenario, with 5 to 6 feet of exposed conductor and multiple parallel runs of 600 kc mil, lashing is highly recommended. The large size and number of conductors increase the potential for movement during a fault condition, which could damage the lugs or other components within the enclosure. Lashing helps to mitigate this risk by providing additional support and preventing excessive movement. The recommended method for lashing surface entrance conductors involves several steps. Firstly, select the appropriate lashing material. Non-metallic cable ties are suitable for most applications, but stainless steel wire is preferred for outdoor installations or environments where greater strength and durability are required. Secondly, lute the lashing material around the conductors and the rim of the box. Ensure that the conductors are bundled tightly together, but avoid compressing the insulation. Thirdly, tighten the lashing material to secure the conductors. Be careful not to over-tighten, as this can damage the insulation or the conductors themselves. Allow for some slack to accommodate conductor expansion and contraction due to temperature changes. This will prevent the lashing from becoming too tight and potentially damaging the conductors. Additional considerations include ensuring that the lashing material is rated for outdoor use. UV resistance is important to prevent the material from deteriorating over time. Inspect the lashing periodically and retighten as needed. Environmental factors can cause the lashing to loosen over time, so regular inspections are necessary to maintain its effectiveness. An alternative to lashing is to use a cable tray or conduit to provide support and protection for the conductors from the point of entry into the box to the main lugs. This method offers a more robust solution, especially in situations where the conductors are exposed to harsh environmental conditions or physical damage. Overall, the common practice of lashing surface entrance conductors enhances the safety and reliability of the electrical system by providing additional support and preventing excessive movement. While not always explicitly required by the NEC, lashing is a prudent measure, especially in situations where the conductors are large, have long spans between supports, or are exposed to potential stress or movement. Implementing these best practices helps to protect the conductors, connections, and equipment, ensuring the long-term performance and safety of the electrical system. When dealing with electrical installations, it's crucial to consider additional factors beyond the immediate lashing requirements. These factors can significantly impact the overall safety and reliability of the electrical system. One important consideration is the environmental conditions to which the surface entrance conductors are exposed. If the conductors are located in an area with high levels of moisture, corrosive substances, or extreme temperatures, it's essential to select lashing materials that are resistant to these conditions. For example, stainless steel lashing wire is a good choice for outdoor installations or areas with high humidity, as it is less likely to corrode than other materials. Similarly, non-metallic cable ties should be UV resistant to prevent them from becoming brittle and breaking down over time when exposed to sunlight. Another consideration is the potential for physical damage to the conductors. If the conductors are located in an area where they could be struck by vehicles or equipment, it's important to provide additional protection. This could include using a cable tray or conduit to shield the conductors from physical impact. In some cases, it may also be necessary to install barriers or guards to prevent accidental contact with the conductors. The size and weight of the conductor should also be taken into account when selecting lashing materials and methods. Larger conductors, such as 600 kcmil, are heavier and require stronger support than smaller conductors. It's important to choose lashing materials that are capable of supporting the weight of the conductors without stretching or breaking. The spacing between supports should also be adjusted to prevent sagging, which can put stress on the connections and insulation. In addition to lashing, it's important to ensure that the surface entrance conductors are properly grounded and bonded. Grounding provides a path for fault current to flow back to the source, helping to protect against electrical shock. Bonding connects all non-current carrying metal parts of the electrical system together, creating a low impedance path for fault current. Proper grounding and bonding are essential for ensuring the safety of the electrical system and preventing electrical hazards. Finally, it's important to inspect the lashing and other support components regularly to ensure that they are in good condition. Over time, lashing materials can become loose, corroded, or damaged, reducing their effectiveness. Regular inspections can help to identify potential problems before they become serious, allowing for timely repairs or replacements. By considering these additional factors and implementing appropriate measures, electrical contractors can ensure that service entrance conductors are properly supported and protected, contributing to the overall safety and reliability of the electrical system. In the context of service entrance conductors entering a 60-inch top hat box, several specific aspects should be taken into consideration. Firstly, the top hat box itself introduces a unique set of challenges due to its size and shape. The conductors must be routed and supported within the box in a way that minimizes stress on the connections and provides adequate clearance for maintenance and inspection. The large size of the box also means that there is more potential for movement and vibration, which can put additional strain on the lashing and support components. The location of the top hat box is also a factor. If the box is located outdoors, it will be exposed to the elements, including rain, snow, wind, and sunlight. This means that the lashing materials must be weather resistant and capable of withstanding extreme temperatures. If the box is located indoors, it may be subject to different environmental conditions such as humidity or dust. The type of equipment being served by the service entrance conductors should also be considered. If the equipment is sensitive to voltage fluctuations or power quality issues, it's important to ensure that the conductors are properly sized and supported to minimize voltage drop and impedance. This may require using larger conductors or adding additional supports to reduce the length of the conductors between supports. The number of parallel runs of conductors is another important factor. Multiple parallel runs can create a significant amount of weight and bulk, which can make it more difficult to properly support the conductors. It's important to use lashing materials and methods that are capable of handling the combined weight of all the conductors. In addition, the conductors should be spaced properly to allow for adequate cooling and prevent overheating. The accessibility of the top hat box is also a consideration. The box should be located in an area that is easily accessible for maintenance and inspection. The conductors should be routed and supported in a way that does not obstruct access to the box or the equipment inside. Finally, it's important to follow all applicable codes and regulations when installing and supporting service entrance conductors. The NEC and local codes provide specific requirements for conductor size, support spacing, grounding, and bonding. Failure to comply with these requirements can result in safety hazards and code violations. By carefully considering these specific aspects and implementing appropriate measures, electrical contractors can ensure that service entrance conductors entering a 60-inch top hat box are properly supported and protected, contributing to the overall safety and reliability of the electrical system. The installation of service entrance conductors, especially in scenarios involving parallel runs and specific enclosure types like a top hat box, necessitates a thorough understanding of relevant electrical codes and standards. The National Electrical Code, or NEC, serves as a primary guideline for safe and effective electrical installations in the United States. Several sections of the NEC directly pertain to the lashing and support requirements for service entrance conductors. As previously mentioned, NEC Section 230.14 stipulates that service entrance conductors must be securely fastened within 6 inches of every point of support and at intervals not exceeding 12 feet. This requirement aims to minimize stress on connections and equipment, particularly during fault conditions or normal operational vibrations. The phrase securely fastened implies that the conductors should be held in place with sufficient strength to prevent movement or displacement under typical stress. Beyond the general support requirements, the NEC provides guidance on the type of materials suitable for lashing and supporting conductors. Section 300.11 addresses securing and supporting wiring methods. While this section covers a broad range of wiring methods, its principles can be applied to the lashing of service entrance conductors. The NEC emphasizes the importance of using materials that are compatible with the conductors and the surrounding environment. For instance, in corrosive environments, the use of stainless steel or other corrosion-resistant materials is recommended to prevent deterioration of the lashing and support components. Section 310.15 and associated tables provide guidance on conductor ampacity and dirting factors. When dealing with parallel runs of conductors, it's crucial to ensure that the conductors are properly sized and spaced to prevent overheating. The NEC specifies the conditions under which conductors must be deaerated, which means reducing their allowable ampacity to account for factors such as ambient temperature and the number of conductors in a raceway or cable. In the context of a top hat box, the NEC requirements for working space around electrical equipment are also relevant. Section 110.26 mandates that sufficient space be provided around electrical equipment to allow for safe operation and maintenance. This includes ensuring that there is adequate clearance for personnel to access the equipment and perform necessary tasks. The lashing and support of service entrance conductors within the top hat box should not obstruct access to the equipment or impede maintenance activities. Local amendments to the NEC may exist, and it's crucial to consult local electrical codes and regulations to ensure compliance. Local jurisdictions may have more stringent requirements or specific interpretations of the NEC that must be followed. The NEC also addresses the grounding and bonding of electrical systems. Section 250 provides detailed requirements for grounding and bonding, which are essential for ensuring electrical safety and preventing shock hazards. The proper grounding and bonding of service entrance conductors and associated equipment is critical for providing a low impedance path for fault current and minimizing the risk of electrical shock. In addition to the NEC, other industry standards and best practices may offer further guidance on the lashing and support of service entrance conductors. Organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA, publish standards and guidelines that can supplement NEC and provide additional insights into safe and effective electrical installations. Compliance with relevant electrical codes and standards is not only essential for safety but also for ensuring the long-term reliability and performance of the electrical system. Proper lashing and support of service entrance conductors can prevent damage to equipment, reduce the risk of electrical hazards, and extend the lifespan of the electrical installation. In conclusion, the lashing and support of service entrance conductors require a thorough understanding of the NEC local codes and industry best practices. By adhering to these guidelines, electrical contractors can ensure that service entrance conductors are properly installed and protected, contributing to the overall safety and reliability of the electrical system. Proper selection of materials for lashing electrical conductors is a critical aspect of ensuring the safety and longevity of an electrical installation. The materials used must be able to withstand the environmental conditions, the weight and tension of the conductors, and potential fault conditions without degrading or failing. Here is a breakdown of common materials and their properties. Non-metallic cable ties are a popular choice for lashing conductors due to their ease of use, affordability, and resistance to corrosion. These ties are typically made from nylon or polypropylene and come in various sizes and strengths. UV-resistant cable ties are essential for outdoor applications to prevent degradation from sunlight exposure. It's important to select cable ties that are rated for the appropriate temperature range and tensile strength for the specific application. Stainless steel cable ties offer superior strength, durability, and resistance to corrosion compared to non-metallic options. These ties are ideal for harsh environments such as those with high humidity, salt spray, or exposure to chemicals. Stainless steel ties are also suitable for applications where high tensile strength is required, such as securing large conductors or supporting heavy loads. Lashing wire is a traditional method of securing conductors, using a continuous strand of wire wrapped around the conductors and support structure. Galvanized steel lashing wire is a common choice due to its strength and resistance to corrosion. However, stainless steel lashing wire provides even greater corrosion resistance and is preferred for harsh environments. The gauge and tensile strength of the lashing wire should be selected based on the size and weight of the conductors being supported. Straps and clamps are used to secure conductors to support structures such as walls, ceilings, or equipment enclosures. These devices are typically made from metal or plastic and come in various shapes and sizes to accommodate different conductor sizes and configurations. Metal straps and clamps should be made from corrosion-resistant materials, such as galvanized steel or stainless steel, to prevent degradation over time. Insulators are used to electrically isolate conductors from support structures, preventing current leakage and shock hazards. These devices are typically made from ceramic, glass, or polymer materials with high dielectric strength. Insulators are essential for supporting bare conductors or conductors with damaged insulation. When selecting materials for lashing electrical conductors, it's important to consider the following factors. Environmental conditions include temperature, humidity, exposure to sunlight, chemicals, and corrosive substances. The material selected should be able to withstand these conditions without degrading or failing. Conductor size and weight determine the required tensile strength and load-bearing capacity of the lashing materials. Larger conductors require stronger materials to prevent sagging or displacement. Electrical requirements include insulation, grounding, and bonding. The lashing material should not interfere with these requirements and should be compatible with the electrical system. Code compliance ensures that the materials selected meet the requirements of the National Electrical Code or NEC and other applicable standards. Cost and availability are also important considerations. While it's important to select high-quality materials, it's also necessary to balance cost and performance. In summary, the selection of appropriate materials for lashing electrical conductors is crucial for ensuring the safety, reliability, and longevity of an electrical installation. By considering the environmental conditions, conductor size and weight, electrical requirements, and code compliance, electrical contractors can choose the best materials for the specific application. Proper installation techniques for lashing electrical conductors are as crucial as selecting the right materials. These techniques ensure that the conductors are securely supported, minimizing the risk of damage or failure over time. Here are some best practices. Firstly, preparation is key. Before beginning the lashing process, inspect the conductors and support structures for any damage or defects. Clean the surfaces to remove any dirt, debris, or corrosion that could interfere with the lashing. Secondly, spacing is important. Follow the NEC guidelines for support spacing, typically within 6 inches of terminations and at intervals not exceeding 12 feet. This spacing ensures that the conductors are adequately supported and prevents sagging or excessive stress on connections. Thirdly, tension control is essential. Apply the appropriate amount of tension when lashing the conductors to the support structures. Over-tightening can damage the insulation or conductors, while under-tightening can result in loose or sagging conductors. Use a tensioning tool or gauge to ensure consistent and proper tension. Fourthly, secure the ends properly. Secure the ends of the lashing material to prevent a raveling or loosening over time. Use appropriate fasteners, such as clips, clamps, or nuts, to ensure a secure and reliable termination. Fifthly, avoid sharp bends. Route the conductors and lashing material to avoid sharp bends or kinks that could damage the insulation or conductors. Use radius bends or flexible conduit to provide smooth transitions. Sixthly, protect against abrasion. Protect the conductors from abrasion or chafing by using padding sleeves or other protective materials at points of contact with support structures. This is particularly important for conductors that are subject to movement or vibration. Seventhly, inspect the installation. After completing the lashing process, inspect the installation to ensure that the conductors are securely supported, properly spaced, and free from damage. Check the tension of the lashing material and make any necessary adjustments. Eighthly, document the installation. Keep a record of the lashing materials used, the support spacing, and any other relevant information. This documentation can be helpful for future maintenance or troubleshooting. When using non-metallic cable ties, ensure that the ties are properly tightened and that the excess tail is cut off flush to prevent snagging or injury. Use a cable tie tensioning tool to achieve consistent and proper tension. When using stainless steel cable ties, use a specialized tool to crimp or lock the ties in place. This tool ensures a secure and reliable connection that will not loosen over time. When using lashing wire, wrap the wire tightly and evenly around the conductors and support structure. Use a lashing tool to apply consistent tension and secure the ends of the wire with a twist or crimp. When using straps or clamps, ensure that the devices are properly sized for the conductors and support structure. Tighten the fasteners to the manufacturer's specifications to ensure a secure and reliable connection. Always follow the manufacturer's instructions and recommendations for the specific lashing materials and tools being used. This will help to ensure a safe and effective installation. By following these proper installation techniques, electrical contractors can ensure that electrical conductors are securely supported, properly protected, and compliant with applicable codes and standards. This will contribute to the overall safety, reliability, and longevity of the electrical system.